YouTube, this is my first video that I'm doing in a module on logarithmic functions, in which we're going to kind of explore what logarithms are and how it is convenient to write things in logarithmic forms, specifically exponential functions. So let's go ahead and start with that. Exponential functions, these functions y equals b to the x, where our base here, we say our base is not equal to 1. We say also our base has to be a positive base, but an exponential function like this, from time to time, of course, we could start with some known y value here and say, let's go solve for the x value up here. And so, of course, with that unknown thing being in the exponent here, we need a way to write this so that we can solve for an exponent. So I guess I could start with this. We say logarithms allow us to solve for exponent values. We'll put it that way, exponent values by rewriting expressions. So basically what we're going to do with logarithms, we're going to be rewriting exponential expressions into what we call logarithmic form, and it's a nifty way to kind of search for unknown values in the exponent. So what that's going to require is that we find the inverse of an exponential function. And of course, again, recall that an exponential function is any function y equals b to the x. We see that here. So if we were to find the inverse of this, remember that what we're going to do is we're going to switch the domains and the ranges of these functions here. So when you switch the domain and range, I suppose you'd say you start by switching your x and your y. So you can see this happening here. We switch domain and range, and so we get this expression here, x equals b to the y. And so solve for y. You know, that's what we want to do next here when we want to find the inverse. Currently, we don't have a way to solve for this y until we talk about what we call logarithmic notation. So we say this question mark here indicates that we don't have a method for solving for this y right now, kind of like what I mentioned up here. But we said to isolate the exponent y, a new notation, just a new way of writing things. We call this logarithmic notation. We need to learn this way of writing things. So we say this notation gives us a way to name the inverse of y equals b to the x. And we say the inverse function of the exponential function with the base of b is what we call the logarithmic function with the base of b. So we're going to start with this. We'd say logarithms, let me try this again here. Logarithms are inverses of exponentials. They are inverses of one another here. So an exponential function here with a base of b would be the inverse of a logarithmic function with a base of b, which we're going to explore here presently. So rewriting things, essentially that's what we're going to be doing with logarithmic things. You'll see the definition here. We say for a logarithmic function with a base of b, we say x is a positive number here. B, our base is a positive number. You have to have a positive base on an exponential thing. But essentially what we're going to see here is this. We say y equals log base b of x is equivalent to b to the y equals x. And so one thing we want to point out here is this. This is the inverse of y equals b to the x. You notice that we have x equals b to the y. So we switched our domain and range. But what we're saying here is that these two statements mean exactly the same thing. So on the left here, we have what we call logarithmic form. Now I can't fit all that here, so I'm going to write log form here, and you can maybe truncate that also. And we're going to refer to this as exponential form. So exponential form. Okay. So these two I guess expressions or two equations, they mean exactly the same thing here, but we read this here as y equals log base b of x. So we'd say log base b of x. And we were using quotations here. And what we're saying here is it's log base b of x, where x is what we're plugging into our function here, okay? So that's, we say a logarithm is a function of x, okay? But these two things mean the same thing here. And so what I want you to notice is this. With both expressions here, the exponential expression, of course, we say anything exponential has a base, and the base here is b. When you look over here, we read this as log base b of x. This little index right here, this subscript, indicates the base of our logarithmic expression. And so with our logarithmic thing here, we're saying b to the power of y equals x. A logarithmic thing, really what we're saying here is when we took b to the power of y, okay, it turned into x, it turned into this thing. What we're looking at here is y is equal to that exponent here. You notice that y is the exponent, and we're saying that when we take b to the power of that y, we get this bigger thing that we're writing right here, the x. So in other words, what do we take this little thing to the power of to get to this bigger written thing here? And it's always to this power of y right here. So one thing is clear. We say a logarithm. If I didn't write this on the other slide, let's write it here. A logarithm is an exponent. That's what a logarithm is. It is an exponent. In other words, you see this y right here? That's the thing we're trying to figure out. What did we take this little thing to the power of to get this bigger written thing? So we say, since these two equations are the same thing here, okay, basically one's just written differently than the other one, then we say that the first equation here, like we listed up here, is in logarithmic form, and the second equation here, of course, is in an exponential form. So we say in the logarithm, y is the exponent. Okay, we got to be clear on this. So a logarithm really is an exponent, and that's what we're dealing with here. And we're going to have to learn how to write these back and forth. So I realize I've been going on and on about this different forms here. Let's just go ahead and practice this. Basically, what I want to practice is, if it's in logarithmic form, like these expressions you see here, let's rewrite it into exponential form. And so what we're going to start with is this. Always just kind of being able to identify the base of the logarithm here. So in our logarithmic thing here, our base is 7. So with any exponential expression, you're going to have something that looks like this. We'd say something to the power of something turned into something. And really what this says here is our base is 7. Well, then what that means is, for us, our base on our exponential expression is 7. And so what I'm going to tell you is, like, I use this little dynamic representation here, but what you do is you start with your subscript and you go across to this other side here, and we say 7 to the power of 3, because that other side there, that y value is our exponent, turns into x. And so what we end up with here is this. We say x is equal to 7 to the third power, which I think is 343. The bottom line here is this. We're a lot more able to solve for what this value is if you write it in an exponential form than when it's written in this logarithmic form right here. So for instance, let's take a look at these other two expressions here. We say I want to write this into exponential form. Something to the power of something turns into something. Let's try this dynamic representation again, starting with my base. We're going to go around the loop here. But basically, we say b is the base on both expressions. B to the power of this 2 right here turns into 25. And so really I'm asking, what did I take to the power of 2 to get 25? And I could easily intuit here that it's either positive or a negative 5 could have done this. And then on this last expression, let's take this one here, and we say, going around the loop here, we say starting at the base, we'd say 4. I was going to say b here, but b is 4. We say 4 to the power of our y here is equal to, and I think this is a 26 here. Yes, I covered it up there. We say 4 to the power of y equals 26. And so really, this is what we're going to start to wrestle with here. And in this particular instance, I suppose I could try to find a value of y, but 26 is not a perfect power of 4. And so in future videos here, what we're going to do is we're going to learn how to find these values. But essentially what we're going to say is, in general, we can write back and forth between the two different forms here, our exponential and logarithmic, by kind of using that loop method that I showed you there with our logarithms, okay? So if that's the case, then we can rewrite from exponential form back to logarithmic form. So looking at all these expressions here, we say, what if I wanted to write this as a logarithm? 2 to the 5th equals x. Then I'd say, well, then I have log base b of something here equals this thing right here. And so I get a lot of people get confused when they go from exponential back to logarithmic, but if you remember that you see this pattern here, it's kind of like, going backwards, I guess. Our base is most definitely in both expressions here, it's got to be 2, okay? And so let me rewrite this here. It's got to be the 2. And so we're saying 2 to the power of what turned into what? Well, it looks like 2 to the power of 5 turns into x. And so we get this expression here that in logarithmic form would look like this. For instance, this here, we would say log, and I'll tell you the quick way to really think about this. Our base here is b. The bases are the same on both of these. But remember, b, it's going to do this little thing right here with respect to what we have for our quantities. So we say b to the power of 3 turns into 27. There would be its logarithmic form. And this one here, we have log to the base b of something turns into something, where our little loop here we'll put in. But we say our base on both expressions, it should be an e. And then we'd say, well, e to the power of what turned into what? Well, e to the power of y turns into 33. So this would be our logarithmic expression here, okay? So we're going to use this to our benefit here as we go forward, rewriting expressions from either logarithmic form into exponential form or exponential form into logarithmic form. Cheers.